Hey guys, I'm Deepanshi and I'm going to throw some light on machine learning and how Azure can make it simpler. First of all, I would like to say that this video is primarily for people who have some basic knowledge of machine learning but now want to go for Azure. But I will try to have to introduce the basic knowledge as well so that the newbies can also understand it. So what is machine learning? Machine learning is building a model to improve that can improve with experience. It is based on the past experiences it has, just like a human being. For example, we learn from our success or our failure. Similarly, a machine learning model also learn what were the output, what was the result from the previous events occurred, and then predict the future results. And as machine learning revolves mainly around predictive analytics, so Azure also focuses on predictive analytics. So now why Azure? Why not coding through R or Python, etc.? Azure makes it help the beginners or professionals as well to save time. Rather than coding, the person can think on how to build the model and how to improve the efficiency. So it is a drag and drop machine learning platform, and it is both for beginners as well and for professionals as well. It is simpler for beginners as obviously if the beginner do not has to code and directly can use the algorithms, then obviously it is simpler. And other than this, a professional can use it, saving his or her time and focusing on on data mining or on the model. Also, the main advantage of Azure is that it makes it easy to deploy. It has the facility that we can deploy our model directly through web services. And we do not need to install anything. We do not need Anaconda or Python or anything. We just have to access it through the web browser. We should have a Microsoft ID to have an Azure account. Okay, so let's come to examples of machine learning. So where do we use machine learning? We use it in detecting in data mining or predicting what will the flight will be delayed. This flight will be delayed or not. Delaying of is mainly due to is basically dependent on weather forecast and the previous history about how many times a flight is delayed. So we can use this to predict if a one particular flight will be delayed the next day or not. Similarly, we can detect frauds as well, credit card fraud or dealer fraud in DTV services, etc. We can recognize patterns as well because there is some or the other similarity or the pattern following up that produces the next pattern. So we can use it in pattern recognition. And a real-time implementation is web search page result. We use Google every day, and we often see that whenever we type something, we get results based on that are very much close to what we actually want to search. So that also uses machine learning to predict what we searched before and what we would now want to search. So, descriptive and predictive analysis. Let's discuss how these are used. When we say that we want to know how many new followers will I get next week, so we use regression algorithm to predict how many new followers will I get next week based on how many followers were there in my last month. How much it increased last month every week. Also, we can use classification algorithm for if you want to predict will this customer click on the top link. Means if there is an ad and I want to have the sorry, have the analysis that if this how popular will this ad be. So if this ad will be clicked or not, we can use classification algorithm, yes or no. Okay. So the basic process to be followed during building any model in machine learning is this. We need to have the objective, the agenda, the what we actually want to build and for what purpose. Okay, and then need to think. Then we need to collect the data based on according to our objective. Then we need to prepare the data. Prepare the data means we have to handle the missing values, the outliers. Outliers are the some of the points that are completely different from the main points. There, it may occur due to some mishandling of data or some mistakes, typing mistakes or mistakes during getting the inputs from the user. Okay, and when we have prepared the data, we have to build the model. So we can use regression models or classification model, clustering model based on what our objective is, and then we have to train the model. And we have once we train the model on the training data set, we need to analyze it. We need to evaluate it on the test data set, that is the result actually good or not. And if we found that the result is good, we can publish it and then we can monitor it, operate it. We can have the web services, we can deploy it and can be used by anyone. So, those who already know machine learning would have been knowing about supervised and unsupervised learning. So, supervised learning is basically when we have the data with us, the previous history with us. We were talking about it in the previous slides as well. So, in predictive algorithms, we have a data set known to us, and along with the input data, we have the output with us. For example, if I know that this is the flight, and I know that if this flight was delayed or not for yesterday, for day before yesterday, and this. So I will explain it with example. So here I have the data set with me from all customers. So I have the customer ID, the gender. Okay, so gender, age, annual income, and the spending score. So here, the first four columns are the feature vectors. It represents the features, and the last column, the spending score, is the outcome. That if this is the data set, then we have to predict for XYZ customer if the spending, what will be his spending score. So to predict the spending score, we need these four columns, and we will analyze it with these four columns at what could be the spending score for the XYZ person. Okay, and this is another example of another one of the data set, that is forest fire data set. So here we can say there are many columns here. So when there are many columns, it is not always important that the outcome we want is dependent on all the columns. So we can select some of the columns and predict the result according to those particular columns only. Let's come back to the slides. So I hope you would have understand what the predictive algorithm actually is. It is a combination of knowing the input data and the outcome. We know the outcome, the spending score. We know the input data is the gender, customer ID, etc. And then based with combining these both, we can have a model that can predict the XYZ customer what will be his spending score. So let's now finish it up with the theory part and go to the practical part of Azure ML Studio. So this is how it looks, and let's start working. You can search Azure ML Studio on Google. Go to the first link and you just need to sign in. I have already signed in, so I will directly get to the main screen. So we can have projects, experiments, web services, etc. You just need to go to the new button that you can see below. I guess you will not be able, you're not able to see that, but just below this dashboard, you will see a new column, and you can just click it and you will get to the empty project, or you can go to the experiment and have a blank experiment. And other than this, you can see there are multiple samples available. You can go through this and see how actually the how actually the ML Studio works, but we will start with a blank experiment and build our own model. Okay, so this is the workplace where we are going to work. The center part is the canvas. The left portion is are the components available to us, and the right section tells about the properties that we select. So we need to drag things here. So for building a model, the first thing that we want is data set. ML Studio provides us some sample data sets to us, but we can have our own data set as well. Going to the data input output section, we can enter data manually, export data, import data, or load train data, etc. Okay, so for now I will go to the sample data set. I will drag the adult census income binary classification data set. Now I have the data set with me. Clicking on right clicking, I can go to dataset and visualize, and now I can see the dataset with me. It has 32,561 columns and rows, and 15 columns, and I can see the visualization of particular column as well. Okay, so just have a look at it. We have these so many columns, and it is not and we have to predict the income. Okay, so it is not compulsory that you have to select all the columns, but you can select if you think that the age, education, and the marital status are the three columns that are dependent and can majorly affect the income. Then you can select that. And how you have to do that is going to the column. You can select columns in dataset through data transformation and manipulation section, or you can search it above here also. Okay, now you have dragged it and you can connect both of them. And now clicking on the select columns in dataset, just go to launch column selector. And now here you can just drag the columns you think are important, will be majorly affecting the income portion. And don't forget to add income as well, because we have to work on it. Okay, so you can randomly choose few. Okay, and just tick. Okay, so now we have the data set with us. Now what? Now we have to split the data set. Why splitting is important? Splitting is important because when we have where we have one common data set, but when we have to evaluate the model, we cannot evaluate on the same data. So we just need some more data set that is different from the training data. Okay, so we will split the data set, and here the fraction is 0.8 because around 80% data, 80% should be the 80 to 20% should be the ratio of training to testing data set. Training data set should always be much greater than the testing data set, and it is preferred to use 80 to 20% ratio, and you can just change it little bit but not much. Okay, so now I have the splitting data set. Now what? Now I will have a model with me. Okay, I can just show you up here. Go to machine learning, initialize model. Okay, so we have anomaly detection, classification, clustering, regression. So you can just choose anyone based on your experience of what you think is better. So for example, just take 2-class regression forest. Okay. Now I have the model with me. Now what next? I have to train the model. So I will go to train. I will drag train. Connect the train model. I'll connect our model with the train model, and the training data set with should be inside the train model. Now what? Now go to the train model and select the go to the launch selector column and select which column you want to have as an output. So that is income for us, right? So we will write income and we will just tick it. Okay, so now we have training data set. We have trained the model. Okay, so after training the model, we need to evaluate. And before evaluating, we need to have the score. Okay, so now why score? When we have trained the model, we need to know if our model is accurate, how much accurate our model is. So we will connect it with the score model and the test data set in the other input, because it is the test data set on which our score will, or based on which our score will be generated, if that test data set is producing the correct output or not. Okay, and then once the score is generated, we will evaluate the model. Evaluating the model means we can just view how much is the error, or what is the how basically visualization is evaluating the model. You can also say. Okay, just a minute. Uh, I hope now you will be able to see bit in a better way. Okay, so now we have built our model. Okay, so now you have to save the model and then run it. You can see the tick, so it is basically building up. So I'm very excited to know how will be our result. It's taking time, my internet is not working so great. You will definitely not take, your model will definitely not take this much time. Don't worry about it. And once it is done, yeah, now it is done. Okay, so you can just right click the evaluate model and go to evaluate results and visualize. And here is the graph. So we can see how our result is there, and what in all the basically the result that we need, the F1 score, the accuracy, we can see it all here. Okay, so you can use different models and just check how which model is giving the best accuracy. Okay, I hope you would have loved it really. So if you want to use another model, you can just not clustering definitely. For example, 2 class base model. Okay, so you can just connect it rather than connecting this, and just do the same process, save, run, and check the evaluate model, the visualization and evaluate model. Okay, so this is how simpler was to use Azure for machine learning. I hope you would like the video, and also I would like to share the cheat sheet with you. So Microsoft provide us with the Azure cheat sheet. So here we have all the algorithms they have in their ML Studio. The clustering, anomaly detection, regression, two classification algorithm, and multi-class classification. And today we used two class regression forest, and you can try any one of them, the linear regression one or the Bayesian linear regression one, or anyone, and just check which one is giving the best results. So it is this much simpler. You do not need to know much of coding or anything like that, and you can even see the score, the visualization thing. Sorry, I just so if you don't even know, I need to build it again. Sorry. So you can, I just wanted to say, just show you that even if you don't know how to get the FN score, or how to visualize it, how to draw the graph or anything, you can just directly easily get overview of your model, how it is looking, how accurate it is basically. So here we have negative examples, the positive examples, the precision, the event score that is majorly seen, the accuracy, etc. Okay. And here we have the cheat sheet. You can just search it on Google, you will get it, and I will also share it, the link of this uh, with the video. Okay, so thank you so much, and I hope you will like the video, and I will try to make more videos related to Azure and other stuff. Thank you.